All right, take your calculators and tell me how to make a table. Stat. Wait, what happened? I thought somebody was telling me what to do. Edit.
What's the difference from stat and second graph?
They're not quite the same, but we're here at this edit thing. I should probably clear my list. What do I want to put in my list? So what are the x values? So 0.0001, 0.001, 0.01, 0.1, 0.3, 0.9, 1, 2, 3, 4, 6, 9, and 10. All right, so I got my x values there. What do I do next? How do I do that on the calculator? Well, I thought you guys knew. So where should I go now? So I just press second, and then what? This one? All right, well, here's what you need to do. You need to have your cursor up on the L2 because you're applying this to the whole list. You see the difference? My cursor's up on L2. My cursor's not on L2. My cursor's up on L2. That's what I want. Okay? And then now you hit the LN button, and then now you have LN open parentheses, and you're going to put in your x values, but your x value is a whole list. So you're going to put in L1. Okay? From where? Second and the number 1. What happened? Did you guys? Oh, that's a bummer. All right. Close the parentheses and hit enter, and then everything is going to get filled in. All right, let's put the logarithm there also. So again, have your cursor up on the list, on the name of the list. The name of the list is L3, and then this time it's LOG, right? Yeah. So LOG, and then what's your x values again? It's an L1. So second function number 1, and then if you look at, it's interesting, if you look at the log, you get kind of nice numbers for the first couple of numbers here. -4, -3, -2, -1. Oh, for both of them. For both of them, you have 0 when x is equal to 1. So I think that's going to be a good indication that we have a logarithm of the number 1. The number 1, your output is going to be 0. Okay? All right, so here's your table. So this is one way to do this. Another way to do this is if you hit y equals. I'm in a different mode here. I'm going to change my mode. So if you hit y equals, have you guys ever used a graphing calculator to graph things?
Yes.
Okay, so let's put the ln function here. And then let's put the log function. And then now, if we want to make a table, we can set the table first. I usually like to have this table set so that I get to put in the values that I want. So we can go to second function and window that sets your table. And then we can start the table. Doesn't matter where you start because if you ask, the independent values are the input values, the x values. So if you click on ask, then you get to put in whatever values you want. If you click on auto, then it's automatically going to set up the table for you, starting in this case at -2 and taking steps of 1. So -2, -1, 0, 1, 2, 3, etc. But if you want control over it, you would click on ask. And then the dependent is going to be automatic based on the functions that you have. Okay, so if we hit second function and graph, then we get to put in the values that we want. So put 0.0001, 0.001, 0.01, 0.1, 0.3, 0.9, etc. So then you can set up your table this way as well. The graph will just be a graph. You won't see the graph of the table, but if you hit graph, then yeah, you'll see the graph, which is also a good thing for us to do. So if you're going to be in the graphing mode, and you would want to graph this anyways, this might be a better table than doing the L1 and L2. So you can click on graph. I have some other stuff here, but here's I need to turn my stats stuff off. So right now my window is set up like this. Do you guys know how to adjust windows? So we could adjust windows. What do you notice about, oh, here's what we can do. Let's go back to the table. So second function and graph. And you can overwrite some of this if you want, but let's try putting in some values. Question? The edit list table stat? Yeah, you can clear it out. Oh, this table is using table set.
But I have a bunch of numbers.
Oh, you're not going to delete it when you change the values. So right now I have a bunch of numbers. If I put in a number here, it'll change automatically. And if you want, are you able to put numbers in? Because remember, if you set second function and table set, all right. Well, let's move on. So the graphs, we can adjust the window for the graphs. Oh, what were we doing? I think we're putting in certain values. Let's go back to the table, second function and graph. And then let's put a -1 here. So remember that if you put a negative number, it's this negative sign down here. And then 1, enter. What happened? So what does that mean? You can't have a negative 1 at least, and if you try more negatives, you'll see that you can't do that. So you can't have negative numbers. So if you look at the graph, again, you notice on the left-hand side of this graph, there's nothing. So 0 is the asymptote, right? Do you guys know all this already? Common sense. I was trying to, and then you guys weren't listening, so I just moved on.
What are you talking about? We were listening the whole time.
No, you weren't. I was trying to, and then I tried to talk over you, and then you guys weren't listening, so I just moved on. Well, whatever. So, if we want to adjust the graph, we can set the window and have it start, since we're not starting at negative numbers, we can start at 0, and that will save some room for our graph and make our graph bigger. So x min, x max 2. I think the largest value that they had here was 10, right? So let's put 10 in here. And then let's graph it again. All right. Which is which graph?
The steeper one is
Wait, which one's steeper? This one? And then this one is LOG?
natural log is wrong.
What? Well, one's LOG, one's LN. So which one's the LN?
The one that goes up.
The one that goes up higher?
Yeah.
Do you know how to tell?
Yeah.
I just saw, when you press graph, the first one graph is that one.
Oh, okay.
That's what I did.
So the other way to tell is if you hit trace, if you hit this trace button, and then if you look at this upper left-hand corner, you're tracing the LN. If you move your arrows left and right, I don't see my cursor. What's happening? You guys know what's happening? Yeah, so there it goes. So this is the LN function, right?
And it'll just follow all the points.
Yeah, and then if you move left and right, it'll follow the points. If you move up and down, you'll switch graphs.
Oh.
Okay? All right. And you can actually put in a specific value. So one of the values that they had here was 6. So if I type 6 in while I'm tracing, 6, and then enter, and then I have 6, and then my y value is 0.77. If you look at the y value that we had for 6, 6.7781, that's for the LOG function. Yeah, we should probably label this.
Wait, how do you do that?
All right, how do you do what again?
Where you just put in any active.
Oh, while you're tracing, so I'm in trace mode right now, and I'm tracing y2 equals LOG. Just type in a number.
Oh, okay.
Just hit 3, enter, and then I'm at 3. You see down here the x value and the y value.
Yeah. Okay. But you can't do that, like, you can't just type in any y.
No. You have to type in the x to get the y, but you can't type in the y to get the x. So I see that this my ln function is a little cut off, so you can adjust the window so that you show more if you want. So let's adjust the window again. This time let's up the y max, and let's make it go, at least when it goes to 10, it says here I'm looking down at the paper, 2.3. So maybe let's just go up to 3. So I'll type 3 for, not the scale, but for the y max. So my windows from 0 to 10 in the x, and the x scale doesn't really matter. The y min is negative 1.5 to a maximum of 3. And then let's graph it. And we get a nicer looking picture that we can identify a little bit better. Oh, sorry, I forgot. Which one was ln again?
First one.
Which, the top one?
Yeah.
The one, yeah.
Oh, but they switch, right? When we're looking at it from this point of view, this is the log function. Sorry, the first one was the ln function, the second one was the log function. And we have to, so this is where the graph kind of might be a little deceiving. It looks like the graph touches the y-axis. It doesn't, right? So it gets really close to it. So we have to identify this as an asymptote, and if you're drawing this by hand, you would normally draw a dotted line there to represent the asymptote. Okay? All right, so that's our graph. If you plug in 0 or negative numbers in the log, you get log is undefined. And what's the domain? Let's talk about the domain then based on this. I don't know what's going on with my computer. So what's the domain for the ln function?
The domain is 0 to
So y equals ln x. The domain is going to go from open parentheses 0, infinity, also open. So infinity is always open, right?
yeah.
So log and ln have the same domain, huh? Interesting. Well, not really, but. What's the range? For log, let's talk about the log first, log. Somebody else? What? Negative 1, 1. Anybody else? Well, let's take a look at some of the y values that we get. The range is the y values, right? Let's look at some of the y values that we get here. We got negative 9, right? So it goes past negative 1. How far down does it go? It's an asymptote, so it keeps going all the way down. This is an asymptote, so it keeps going all the way down. So it goes from negative infinity. And does this ever get topped off? Is there an asymptote up on top?
Yeah.
Think so? You guys think? It looks like it, huh? It looks like it's going to start leveling off. Okay, well, yeah, so let's, I don't know if our calculators can handle this. Let's see. Oh, I don't know. ln or log, it doesn't matter. Let's do the ln. So let's do ln of 1,000, 10,000. You think it's going to blow up? That's only 13.
So
Let's try. Oh, let's use scientific notation. Let's find the ln of. Oh, wait, too many ln's. Ln of 10, and scientific notation is that E, the double E. So if I press second function in the comma, so now I'm ready to put, this is 10 times 10 to whatever power. Okay, so let's pick a big power. No, that's too big. Calculator is not. Well, let's start with 99. So this is 10 with an additional 99 zeros. So this is 10 with 100 zeros after it. Do you guys know what that is?
yeah.
What is it? It's a Google. Did you know that that was a Google?
Yeah.
It's just 100 zeros. It's 1 with 100 zeros. That's a Google. Did you guys know that? Now you do. If you Google, Google, Google. Google. So this mathematician had this little kid who was saying, Google, Google. And he decided to name this number a Google.
So what is the Google? The
That's the ln of Google is, it's 2. So you know when that happens, I go to. You guys know about Wolfram Alpha?
Yeah. What was that?
Oh yeah, Siri. Siri. Whenever you ask Siri something, it goes to Wolfram Alpha. Did you know that? Now you know. Damn, you guys are learning too much today. I don't know.
So what are we going to put down for the range?
Well, we're trying to figure out if this thing has a cap on top, right?
Right.
And so that's why we're messing around and wasting time right now.
So, since Siri does this, we put in a question like, so what is 0 divided by 0?
Yeah, if you could ask what's 0 divided by 0. So ln of a Google, which is, a Google is a huge number, right?
Yeah.
ln of a Google is only 230.
Yeah, but it still keeps going.
Right, but it still keeps going, right? So here's our, not really a proof, but here's some justification that if we put a really large number in,
It keeps going up. There's no block. There's no stop. But its rate of increase is lower.
it's really, really slow, yeah.
But it still goes up.
But it still goes up and goes on forever. So the rate of increase is really, really slow, but it doesn't stop. And so that's the important thing. And now we get to put infinity here. So that, yeah. Yeah. Or it's the inverse of the of the exponential function, right? And if you look at the exponential function, the domain of the exponential function goes on forever. So that's the same reasoning. And so that would work for the ln as well. Yeah, so, yeah, I guess. Let's put this on another page. So one way to try to justify this is that the inverse of this what's the inverse function for this?
For which one?
For the ln,
E to the ln.
e to the x, right?
Yeah. And then the other one's 10 to the
And the other one's 10 to the x. Now, if you look at e to the x, the graph looks like this. More importantly, the domain equals all real numbers. And then the range is just all the positive. And so it's not a coincidence, and this is what happens when you have inverse function, that the domain and the range are switched. And the same goes for the ln, the log function, the log function, the base 10. Okay, so when you're dealing with inverses, the domain and range are essentially switched. Okay? All right. Let's take a look at the next page. It says find the domain of the following functions. Where is it? So remember that the log function, the domain of the log function is what? All real numbers? No, try it again. Domain of the log function, just the log. Let's keep this on the side. So the domain
of the log is 0.
and the range is all real numbers. So here he's asking us to find the domain of the following functions. So what we want to do is we want to try to figure out what x values we can put in so that in the log function you'll have no negative numbers. Yeah, log or ln. Well, you know. Whoops. Oh, never mind. It's the same. I won't change it. Okay, so what kind of x values can we put in here? Is it okay to put anything?
Yes.
Except what? Except 0. So this would be all real numbers. Do you guys use this for real numbers?
Yeah.
Okay. Minus 0. Do you guys use a minus or backslash or something?
Equal sign with like a cross through it.
Oh, yeah, yeah.
Or we do like
Oh, okay. He likes union?
Interval notation 0.
And then 0 to infinity. Okay.
Or if that, whatever that is.
All right, so I won't do that. All right, let's take a look at this one. LOG of this thing. Now, remember that we want the thing inside of the logarithm to be positive, right? So the way to find this, any hints on how to find this domain? Because this is what's inside of the logarithm. It's inside of the logarithm is 3 minus x, right?
Yeah, so
And we want this to be bigger than 0.
it has to be greater than 3.
So minus x is bigger than negative 3. And I think if we, isn't there some rule where you divide by negative?
The symbol, if you divide by negative.
So I can put any number that's less than 3, but I can't put like 4 or 5 or 6 in here. Because if I do, it'll be a negative number. I can't take the ln of a negative number. This one's a little trickier. All real numbers except 0? Well, it's inside of a logarithm. So what should it be? So it's all real numbers bigger than 0. Okay, we have a little bit of a problem there, though, if we say all real numbers bigger than 0. Because if we put a like a 0.5 here, this thing will be negative. And then I can't put a negative number there. Greater than 1 or 10? No, log 10 is 1. So what we want to say here is that we want to say that log of x has to be bigger than 0 for it to work for the ln. And log of x is bigger than 0 when x is bigger than 1. So those chain rule issues are going to be tricky. Because it's log and ln have the same 0 to infinity domain, and then this is the outer function is the ln function. So the things that go in there are the log of x, and we want all the log of x stuff to be positive because we can't put any negative numbers in here. All right, we got one more. Should we do it? All right, so when you square something, it doesn't matter, right? Positive or negative. So we just want to make sure that the ln is safe. So what x values can we put into the ln? Anything but 0? So I can put negative numbers in there? Oh, so the square is on the outside. So it has to be bigger than 0. It has to be bigger than 0. All right. So he was going to give you guys a quiz, but he decided not to. So I guess you guys are good. Good luck with this stuff. And if you guys make it to Calculus 3, I'll be there waiting for you.
I'll be coming to you.